get into the mix of things here in optics with a little bit of a discussion on lens equations. And it's really two separate equations that we will try to merge together at the end. But for the beginning here, let us start by working on this problem for a converging lens. So let's say I have this lens right here that is converging. That's a converging lens. In other words, if I shine some rays at it, the rays will converge on the other side. And this is my object here, this arrow here. All right, now let's see if I have some rays that come into this object. So let's say if I have a ray that is parallel to the principal axis, so if it goes through here like so, and this is supposed to be parallel, then when it hits the lens, it's going to refract, or it's going to move off in this direction. And this is a somewhat gross approximation, but but it's a decent one, I guess. Okay, and then let's say I have a ray here that, you know, the light rays from this object is going to come off in all kinds of different directions, but I'm gonna have two rays here that meet and join at this point here. Okay. Now, at the spot where this point, where the two beams of light or the two rays of light intersect, that is where our image is actually going to occur. Alright, so I've cleaned up the picture a little bit there, so the rays are straight like a light ray would be. Let's do some labeling here. So at the point where the diffracted ray hits the principal axis, this point here we call F. Okay. And we know that the distance from the center of the lens to F would be the focal lens. I'm just gonna name these points. Let's see, we'll call that A. Let's change the colors here. Let's get a purple one. All right, so I'm gonna name this point here A. I'm gonna name this point here B. I'll call this point O for object, and I'll call this point here I for image. And let's list out some of these lengths. This height here, from O down to the bottom here, we'll call this H sub O for the height of the object. And this length here, we will call this H sub I for the height of the image. And what we want to do is find some sort of equation that relates the distances between the object and the lens, the distance between the image and the lens, and the focal length. So before I go too far and get too far ahead of myself, let's label this length right here to F for focal length. So that's from the center of the lens to the focus, to the focal point. Okay? I am going to label this length here. This is known from previous work as the object distance, so I'm going to call that D sub O. And then this length right here from A to big I, I'm going to label that D sub I for the image distance. So from this picture, understanding how ray tracing works, we're going to be able to derive and come up with an equation that relates everything, that relates the distance. We really want to relate DO, DI, and F. Alright, so now I am going to make some geometric statements here. So triangle ABF and triangle, I guess I'll call this point here DIF, are similar to each other. These two angles here are vertical angles, so they're congruent. You have 90-degree angles here, so those are congruent. So the two triangles must be similar. So triangle ABF is similar to triangle DIF. And so we can then make some similarity or proportion statement. So we can say that H sub I, that's this height, over H sub O, that's the object height, is equal to this length, which is df. Now rather than say df, I'm going to say d sub I minus f, and over this length right here, af, which is just the focal length, little f right here. Okay, so that's the first triangle that we can extract from here and see that they are similar. All right, now let's look at another pair of triangles that must also be similar, and I'm going to highlight it would be this triangle here, so OAE, and this triangle here. Okay. That would be DIA. So triangle OAE is similar to triangle IAD. And from that, we can also come up with another equation with two proportions that are equal to each other. Now notice that HI here is still a part of the green triangle, so I can say that H sub I and H sub O is still a part of this green triangle over H sub O is equal to this length here, DA. Okay? But DA, the segment DA, is really D sub I, or the image distance. And then on the left side here, over EA. But EA here is really the object distance. So that's D sub O. Now, I have two equations that are exactly equal to each other. This one, the purple one and the green one, they both have HI over HO. So we can do is we can set those two equal to each other and then do a little bit of algebra. So I can say that DI minus F over F is equal to DI over D sub I over D sub O. On the left side here, I can just split the fraction. D sub I over F minus F over F is equal to D sub I over D sub O. Then let's simplify one step further. D sub I over F minus 1 is equal to D sub I over D sub O. Right. And let's continue over here. And now now this is actually correct. This equation is perfectly correct. There is nothing wrong with it, but we can take it yet one step further and divide both sides by D sub I. Divide everything. So D sub I over F, that's just going to be 1 over F, minus 1 here divided by D sub I, that's just going to be 1 over D sub I, and then D sub I over D sub O, the D sub I goes away, so I get 1 over D sub O. Rearrange a little bit, and we get 1 over F equals 1 over D sub O plus 1 over D sub I. So there you go. That is the first lens equation that we're going to use. In the next video, we are going to look at the lens equation for a diverging lens. Thank you for watching, and have a wonderful day.